Hello my friends, today I am going to discuss a problem, and this is also given in Pathfinder, but originally it is taken from 200 more puzzling problems. So today I will discuss the problem from the point of view of 200 more puzzling problems, and it will be a second method after the method I saw on Ramit sir channel. So his channel link is given in the description. You can visit his channel for the second method, or the video link is given in the description. You can just go to that and please enjoy the solution. So here you can see that there is a plate. There are two plates given. Okay, you can just see the problem in Pathfinder. It is in that problem the plates are of irregular shape, but here I have, because since they are infinite plates, or you can just say that they are not finite, I can take them of any shape. Okay, let us assume that they are rectangular. Okay, so first of all I would like to tell you that what is the magnitude of the approximate magnitude and the approximate direction of the electric field at point P, which is at a height h above the midpoint of the edge of the upper plate's edges. So here is the upper plate edge, and it is also infinite because we know that this is an infinite plate, or this is a finite side and it is a regular in shape. The midpoint, at the midpoint there is a point P at height h, and at that point you need to find the electric field, the direction of the electric field and the magnitude of the electric field. So this question basically asks you about the fringing effect in a capacitor like system. Okay, so fringing effect in the capacitor like system. So here you can see that the height h is very less than the edge length and very greater than the d. So here the inequality is already given. So let us see the solution. As here you can see that the small pieces of the upper positively charged and the lower negatively charged plates that subtend the same solid angle delta psi at the point, they cover each other when viewed from the point P. It means that if we are standing at point P, let us assume that we are standing at point P and we are seeing at the system. So after seeing at the system, we can say that some portion of the lower plate and the upper plate, they coincide by the means of solid angle. Okay, so by that means I can say that, here I will show you in a zoom way. So you can see that these red lines are the margin markers. Okay, so the whole lower plate, you can see, if I join if I join the lower plate from all the edges of the lower plate, this edge, this edge, this edge to the point P, I can see that not whole of the upper plate is covered. Okay, it means that some of the margin is left. From the diagram you can see that these are the margin markers. Okay, they tell you that this amount of upper plate is left, this amount of upper plate is left. Okay, and you can see that this will come at infinity, but for now I have taken it to be somewhere and at a finite point. Okay, at a finite point, but it will surely go to infinity. Okay, so here I have taken a finite system. After some time I will just take it to be non-finite system. Okay, so here you can see that let us try to understand. So the same solid angle, because the whole of the lower plane and this portion, the unshaded portion of the upper plane subtend the same solid angle, the net electric field due to this and this combined will give a 0, and all the amount of electric field we will get is from the margin elements. Okay, the margin elements will give the electric field at this point. Okay, so let us see. P, they produce the same amount of electric field but in opposite direction. So we will say that the net electric field is cancelled due to the these two you can say that the two portions that subtend the same solid angle. Okay, now we can just see here that the electric field produced by the lower plate is completely cancelled out by that part of the upper disc, that, sorry for the disc, it is plate, that subtends the same solid angle at P, that is the whole lower plate by the region shown in the margin marker. Okay, so this unshaded region cancels the whole field of the lower plate, so the lower plate is nearly negligible. In our case, we have to calculate the electric field only due to the positive plate, and that too also the margin portion. Okay, the portion in the margin, okay, the shaded portion. Okay, so for that I take an element at an angle, say psi, from the midpoint of the vertical upper plate, and an element of del psi. Okay, del psi, del psi. So we'll take delta psi, not d psi. So please be sure that we are taking delta psi, not d psi. Okay, so I have written that too. So the task is reduced to determining the net electric field at P generated by the marginal region. Assume for now something finite in length, because it will not depend whether it is finite or infinite. It will never depend on the edge length, edge type and everything. It can be regular, irregular, any type of. So for regular consideration I am taking a regular type of figure. Okay, so let us go to the next page. And here, from the similar triangle, okay, from similar triangle we can say from the front view. Okay, if we take the front view of the system, here you can see that from one we will see from this side. Okay, from this side I will see the front view, and from this side I will see the side view. From this side, you can just understand, from this side and this side I will see from these two sides. Okay, so from similar triangles I can say that this is XA. The width of the margin will not be same. Okay, the width of the margin will not be same here. Here it will be XA and here it will be XB. I have assumed that it is XA and XB. Okay, so it will not behave as a square that all sides are equal. Okay, so here you can see that this is XA and this is nearly a by 2, because XA is nearly very small, so I have taken it approximately to be a by 2. So this is H, a by 2, XA and D. From similarity I can get this result, and this is the most important thing that will matter for me, because this will go to infinity. From the side view I can say that this will go to infinity somewhere very back, so it is not considerable in our solution, but I have given it for other purposes. Okay, so BD by H you can just see from the figure, this is also approximately B by 2. So from the similar triangles we can say that from the front view and the side view. Now from the geometry of the figure, okay, if we need to find this r distance, that the element which makes from the P, you can just see that this is a by 2 sin psi. How I get that? You can just see from the geometry of the figure that this distance is a by 2 sin psi. This is a by 2, this is psi, this is a by 2 sin psi. Now a by 2 sin psi square and h square. Now since here a is very greater than h, I can say that r is approximately a by 2 sin psi. Okay, now second thing, I want to find the edge length of this element, edge length. So you can see that this is a by 2 sin psi, this is a by 2 sin psi d psi, and this is perpendicular in perpendicular. So here it is again delta psi because of parallel lines, psi here also psi, and then here also psi. Okay, so a by 2 sin psi delta psi, and here from I can say that sin psi is a by 2 sin psi delta psi and the edge length delta L. So from that result I will be able to get delta L is equals to a by 2 sin square psi del psi. Now I write the charge on the that sheet or that element. So I write the charge from similar approximations from all the values that I get, and now I approximate it and I get that you can get this relation. So here I can say that this is r square, and q by r square is simply independent of a, b. It is just dependent on d, h and del psi. What was del psi? Let me remind you of that. Okay, so del psi was the angle subtended at this point by the element. Okay, by the element. This will help us later in our further journey. Okay, here you can see that h is very less than a. Its direction is roughly horizontal. Okay, in our field we can't see that because it is not to scale. Okay, the result is independent of a, b and psi. The same is true for all elements of the margin for given d and h. Okay, you can just you just know that. And the magnitude of the electric field depend only on the angles they subtend at p dash. Okay, p dash, the point at the plate, not at p. Okay. Okay, now let us assume that this is a sort of, you can just say, the conical sort of figure. Okay, the element nearly semicircular. I have taken nearly semicircular. Okay, now see, you can just say that this will be, the figure will be like that. The horizontal electric field, you can just see that I have shown here, the electric field will be nearly horizontal. Okay, it will be nearly horizontal near the point P, and you can just see from the figure that it is a fringing field of a capacitor like system. Okay, so here you can say that from each as you can say, from each del E, from each delta E, there will be a del psi type of thing that will become that we will see here. And this is the perimeter of a semicircle. Okay, the perimeter of a semicircle, as del psi tends to 0, this is a semicircle. So we just mark the length of the perimeter by integrating it, or you can just do simple summation. It will sum up to pi, and you will get sigma d upon 4 epsilon naught h. This is the length of the perimeter. So now we have, and this is the diameter, E is the diameter, and this is the perimeter. So we will just say that L is equals to pi r, and pi r is equal to sigma d upon 4 epsilon naught h. Now the magnitude of the electric field is 2r, because it's the diameter. So we'll get sigma d upon 2 pi epsilon naught h, and this is the answer. Okay, so you can just see the approximate diagrams here. This is a fringing type of field, and we have found the magnitude that it depends only on the separation between the plates and the height of the point. It doesn't depend upon the shape of the plates, unless and until they are infinite in size. Okay, so the shape doesn't matter. What matters is h, d, and these inequalities that we see here, that h is very less than a, and this inequality is very important in our consideration, that d is very less than h, and h is also very less than the edge length. This means that this should be an infinite system. Hope you like the solution, and you can surely visit the second sort of solution that is relatively more easier. You can just see it is more it is less complex, and it is on Ramiz Zaman. Channel name is Ramiz Zaman, and he is a very nice teacher. What to say about him? So thank you for watching the video.